Dear students, last class we discussed about Newton-Raphson iterative method. I hope all of you understand the procedure. Now we are going to discuss about Regula-Falsi iterative method, the second method in a numerical techniques. The Regula-Falsi iterative formula is given by x is equal to a into f of b minus b into f of a divided by f of b minus f of e. The simplest formula in a numerical techniques. First, we need to find out the location of a root, that is x belongs to a comma b. We know the procedure already in the Newton-Raphson method. A comma b is nothing but this is called the location of a root. X belongs to minus 2 comma minus 3 in that particular example. Now using this a comma b, we need to find the iterative values of x until the two consecutive iterative value of x should be equal. The difference between the Newton-Raphson and Regula-Falsi method is, in Newton-Raphson method, we won't disturb the interval throughout the problem. This interval will remain the same throughout the problem. Using this, first we'll take initial approximation. Using initial approximation, we'll find the first iteration. And using this, we'll find the second iteration. Using second iteration, we'll find the third iteration. Using third iteration, we'll find the fourth iteration. But here, in Regula-Falsi iterative method, each step we need to consider new interval a comma b. I will explain how to take new interval in each step with an example. First, consider a problem. Find the root of an equation x log x to the base 10 minus 1.2 is equal to 0. So this is a non-algebraic equation because this equation involving non-algebraic term. And observe the log function. Log to the base 10 we have. So in a calculator, we need to use log option, not natural log, because here we have a base 10. When you have a base 10, use the calci log. When you don't have any base here, then use natural log, that is ln. So first we need to find the location of a root. So for that, consider the given equation as f of x and find out the location by replacing x by 1, 2, 3. I told you already, when you have a log function, we won't start from 0 because log 0 is not defined. So we'll take f of 1 first. The value of f of 1 is negative. So I want to go for the next value until I will get the positive value. So we'll take f of 2. F of 2 is also negative. So I want to continue further. So I will go for f of 3. F of 3 is positive. So now one is negative, another one is positive. So this is enough. So this is the interval, the location. X belongs to 2 comma 3. Now we can assign the values. I will assign a is equal to 2 and the value obtained from 2 is minus 0.6. So f of a is minus 0.6. And I will assign b is equal to 3 and the value obtained from 3 is plus 0.3. So f of b is 0.23. Now consider the Regula-Falsi iterative formula and construct a table. The table requires the formula values, that is a, f of a, b, f of b, x value, iterative value of x and f of x. Now first consider the initial values. A is 2, f of a is minus 0.6, b is 3 and f of b is 0.23. Using these values in the formula, find the first iterative value of x. If you substitute these values in the formula, the first iteration is 2.7229. So this is my first iteration. Now substitute this first iteration in the function f of x. So when you replace x by 2.7229, the functional value is minus 0.0155. Now to find out the second iteration, I want to find the new interval. The technique is compare f of x with the f of a and f of b. Observe the sign of f of x. F of x is negative here. So f of a is negative and f of b is positive. We need to replace the same sign column. So here I am going to replace f of a and f of a by a and f of a by the new value of x and f of x. So the new a will becomes the first iteration of x, and f of a will become the first f of x value. B and f of b will remain the same. Now using this updated value, find out the second iteration of x. Now compare the first and second iterative values. So these two values are not equal here. These two values are not equal. So I want to repeat the procedure again. Now substitute the second iterative value in the function f of x. We will get minus 0.0002. Again, this is negative. So I want to go for the third iteration because the first and second iteration values are not equal. So now once again observe the f of x column. F of x is negative. So f of b is positive. So don't disturb f of b. F of x is negative, so I will go with the f of a. So replace a and f of a by the new value of x and new value of f of x. So a will becomes 2.7404. F of a will becomes minus 0.0002. B and f of b will remain the same. Now use this updated value. The third iteration is 2.7406. The second and the third iterations are not equal. So we need to go for one more iteration. For that I want to reduce once again the interval. For that replace this third iteration of x in f of x. So you will get minus 0.00004. So again a negative. So I will replace this negative value by a and f of a. So the new value of a will become the third iteration of x, and f of a will becomes new f of x. B, f of b will remain the same. Use this updated value in the formula. The fourth iteration is 2.7406. The third and fourth iterative value of x equal. Therefore, the required solution is 2.7406. So this is the working procedure of Regula-Falsi iterative method. So here the important step is reducing the interval in each iteration. To reduce the interval, compare the f of x sign with the f of a and f of b. If f of x sign is same as f of a, then replace a f of a by x f of x. If f of x's sign is same as f of b, then replace b and f of b by x and f of x. So this is very important in Regula-Falsi iterative method. So first practice this problem. In the next class I will take two more problems. Thank you.